Welcome to this video, lesson 2-4. The topic we're going to talk about today is the limit definition of a derivative. A huge topic in calculus and very important as we go forward in the class. You can kind of say Calculus 1 really is founded on the derivative. And today we're going to talk about the limit definition, just talk about some basics of what a derivative is exactly and how we kind of go about calculating it. Okay, so with that, we're going to go ahead, we're going to jump right in, and we'll just start off here reading the text. It says, any non-vertical line has the same slope at every single point. In calculus, we frequently deal with the slope of the curve. The slope of a curve is defined to be the same as the slope of the curve's tangent line at any given point. So to find the slope of a tangent line, we use a limit of the slope of a secant line. So pretty much what this is saying, and if I zoom in here, you guys are familiar with the slope as being calculated between 2 points. If I take, let me use a different color here. I'll use green. So this point here and this point here, and if I want to calculate the slope, I'm going to calculate delta y, right, which is it's right over here. So here's delta y divided by delta x, okay? And this is the secant line, okay? So delta y over delta x. Now, calculus, you can say, is the study of instantaneous rates of change. So forget between the slope between those 2 points. I don't care about those 2 points. What I do care about is I'm going to choose purple. I want the slope at this point. So at that point specifically, what is the rate of change? How is it changing? So to find the slope at any point, this is what we call the tangent line. Okay, so that's very, very important. Okay, so the slope of a tangent line, okay, is what we're gonna call a derivative. Okay, so what's the rate of change at any one specific point? So how do I bridge this gap? Right, this is calculus in purple. Calculus. That's his calculus, I promise. Okay, and then up here in green, this is where you guys are coming from. This is your perspective of slope. So what I want to do, right, is I'm going to go to what we call delta x here. So the distance between my 2 points. So from here to here. What I want to do is I want to shrink this distance, right? I want maybe to calculate this slope. Calculate this slope. Calculate the points between this slope here. I'm going to calculate the slope between these 2 points. So you can see, right, my x values are pushing towards x, right? And we know from the study of limits that when I approach a value, right, from a certain point, this is called a limit, right? So ideally, we could calculate the slope at this point if I can get infinitesimally close, right? I'm going to shrink this gap to where this blue line ends up going on and matching this red line, the tangent line. Okay, so I want the secant line to be the tangent line, and this is how we calculate the slope at any given point, at instantaneous rate of change. Okay, so we'll just go over here and we'll look at our definitions. So you guys agree, right, that delta y is the function of x plus delta x, okay, that's this value here, right, minus f of x, okay, that's delta x, or sorry, messed up, that's delta x, delta y, Schwarberg, okay, so here's delta y, right, this minus this, okay, that's delta y, over delta x, right? The change in x. Okay, so what we want to do is we're going to take this idea, and what we're going to do is we're going to take the limit as x approaches 0, right? I want this x value, delta x, to shrink to 0, and that will give us instantaneous rate of change. So the slope of a tangent line is called the derivative. This is very important. The derivative, it's the slope of a tangent line. Okay, so when you're given the slope of a tangent line, and they ask you, what's the derivative? Well, they gave you the answer, okay? You just need to connect these two ideas. This is very important here. I'll highlight this for you. When I highlight, you highlight. When I highlight, you highlight. Okay, so it's called the derivative. Now, most commonly used symbol for the derivative is f prime of x. F prime of x. And I want you to say this and write this with me. F prime of x. Okay, that's how you pronounce that. F prime. I don't know why I put the parentheses there. F prime of x. Okay, and then also there's some other notations that you can use. Here we have f prime of x. The most popular one, I think, here, y prime. Super easy. It's a y and then a hyphen, okay? We have dy dx, and then the d stands is the derivative. So you say the derivative of y with respect to the derivative of x, okay? And if you're in function notation, again, you can have the derivative of f of x with respect to the derivative of x, of f of x, okay? And you also have m sub tan, so that's the slope, right, of a tangent line. We know that m means slope. We know this, Schwarberg. That's so math 1, okay? And then here we go. This is the limit definition. Limit definition. There it is, right? F of x plus delta x minus f of x divided by delta x. Now, in another form that you might see is with, instead of delta x, we use h values. Let's say the limit as h goes to 0. And these two, I hope you see, are exactly the same thing, right? They just, instead of using a delta x, they use a h. This mathematician was lazy. He's like, why draw a triangle and an x when I can just write h? Okay, so maybe it's a good idea. All right, so that's the limit definition. Now, I want to talk about vertical line. So a vertical line, we know that has no slope, right? So if I take the tangent of a vertical line, okay, I take a point, and I want to draw a line through that point, you know, there's no slope, okay? So a curve has no derivative at any point where it has a vertical tangent line. So, you can't take it, right, for a vertical line. You can't take the derivative. Another point that you can't take the derivative of is a cusp. And what a cusp is if you have 2 points and they come boop, to a point, okay? Again, I'll do that. Boop, right? So at like this point where my fingers, they're touching, okay? You can't take a derivative there. And if you can't take a derivative, it's said to be not differentiable, okay? So the process of taking a derivative is called differentiation, right? Or if you can differentiate, then it's said to be differentiable, right? So in this video, we just purely talked about the limit definition. This is more of a concept video, the big idea. And then in the next examples, we're going to look at some examples using the limit definition. And then a third video will be on the alternate form. Oh, I'm still small. Hi, I'm big. Okay, I'm going to go. Bye. Ella says this.